Hello, this is David. We're going to discuss today wiring up the Elpas local controller, the ELC. The truth is that the same holds true for the RF IP reader. The only difference in the hardware is in the controller you've got this expansion card. The RF reader, you just have the motherboard. The controller also has control functionality in its firmware, but the hardware is identical. Okay, so let's have a look at the hardware here. Let's start from this point right here. This is the bus jack. Okay, so we can grab a 6-pin RJ12 connector or 6-pin cable, 3 pairs, and connect it between the reader and a junction box. We see we've got, in this case, in the junction box, we've got power supply coming in to the DC connector. That'll be anywhere from 12 or 24 volts. Okay, and then this cable, the 3-pair 6-wire, carry both DC as well as data. On the cover of the device, you see we have a pin out, so you see that pin 1 and 2 are plus minus, then the data AB, and then minus plus. So the extreme pins are plus, one inside is the minus, and then the data. Okay, so that is the bus connector. Now when we have the expansion card, we have 3 more bus connectors. They're all in parallel. However, you cannot power the entire controller from these. In other words, if you're bringing the power from the network, then it's via this connector. Now, in addition to this connector, you can also wire the power and the bus data to this terminal block here. You can see 4 terminals. The orange and the orange stripe is for the DC, plus and minus, and then the blue and the blue stripe is for the data. So you can actually daisy chain your hardware from terminal block to terminal block, or you can use the modular jack. Okay, you can power directly to this terminal. Bring your power supply to these terminals, and that will power the entire bus. Or again, you can power it to a junction box or any of the devices on the bus, and then the power will propagate over the bus. There's some bus general rules. Up to 16 devices total on the bus, including the IP device, 1 IP device, 1 master, and the rest are strictly bus. It is a bus topology. However, the stub cables from the bus to the device can be up to 10 meters. Typically, you would use a junction box, and the backbone would go from these punch-down terminals using 4 pair. 1 pair, the blue pair, for the data, and the rest plus minus, plus minus, plus minus for the power. So if each wire can carry about 500 milli, so you can carry about 1.5 amps over a Cat5 cable. At the ends of the bus, you have to terminate with 100 ohms, and that's why we provide you with this terminal block, which is for the data pair. Again, this is regular Cat5 type wire, which is about a 26 gauge, and then but 3 pairs rather than 4. So you can crimp your own cable. All right, so that's hooking up the bus. Then we've got some additional terminals here. We've got open collector 1 and open collector 2. Those are 2 open collector outputs. They're limited to 100 milliamps. So if you're going to use these outputs to drive anything of greater than 100 milliamps, you will need a relay and then the ground. Okay, this ground repeats itself, by the way, here and here and here. So you got plenty of ground points on this device. This is the input. Okay. Ground, another ground point, and in. All of the Elpas inputs are 4 discrete levels for open, close, and short, and break of end of line. This is the motherboard, and this you get standard on an RF reader as well. Every bus device in Elpas bus device contains IOs, so you can use those to monitor and drive and actuate equipment. You've got, of course, the Ethernet connector. Now, this Ethernet connector's got this little lever because the pin for connecting the RJ45 connector is on the bottom. So in order to, when we ship it with this expansion card, i.e. the ELC wall-mounted device, then in order to actually remove the cable, you got to push it up with this lever. Okay. These are all inputs. So we've got 6 inputs here, plus this one input. It's a total of 7 inputs on this device. Again, they're all supervised. This corner connector is a battery charger, and it's a connector for a backup battery. And it will monitor that battery and stuff and alert in the event that you've got trouble with the battery. That is why we have an alert in Iris that triggers when the voltage falls below 16 volts. So if you're powering with 24 volts and you switch over to backup battery, you'll get that alert. If you're powering normally with 12, then you're not going to get that alert. Okay. Now we've got 2 amp relays, and as I said, 3 more RS-45 connectors for the bus. They're all in parallel, so it's a single bus. So total RS-45 bus connectors is 4. So theoretically, you can operate without if all you have is your controller and let's say 1 or 2 bus devices, then you do not need a junction box. You can pull it right off of these connectors. So let's say you have 2 doors, so you're driving the locks with 2 relays, an input perhaps for monitoring the door position. No, we have lots of inputs. So let's say a door position and request to exit for each exit. That's 2 doors is 4. 4. You can actually do 3 doors. So you have 3 locks here, 3 relays, and 2 inputs for each door can be used for controls. And then you drop the Prox card readers or the Elpas readers, the Elpas active RFID readers to these devices here. So again, you can use a junction box, or you can manage without the junction box if you only have up to 4 bus devices coming off of here. Okay? Again, you're limited to 10 meters. If you need to run more than 10 meters, then of course you need to run a backbone and then come off of that with a junction box. This is the tamper. So we get an alarm in the event that the lid is opened. That's about it. The relays can all be wired normally open, normally closed. And you've got you've got a ground for every 2 inputs here for your convenience. Again, I want to reiterate that the antenna needs to be kept vertical if you're using if you're installing an RF reader or a ELC. So the antenna must be kept vertical. Yep, that's about it. If you have any questions, get online, go to our support site, or contact one of our tech support engineers. Thanks.